Starting now. Hello there. Not got any patrons here yet, but hopefully they'll be joining soon. Not quite sure what to start with, the happy stuff or the nightmare of the last 3 weeks. I guess the happy stuff, which is, I don't know if anyone's actually seen the films yet. Avengers Infinity War, which I've got to admit I was a little skeptical about, but oh my god, that was a good film. And then I thought it's going to be a long time before I see a better film than that. And then comes along Deadpool 2, which that's a very funny film. All right, let me just check that all the links are good. And hopefully people are joining. So I've done something right. Cool. But people should be joining because I set 2 links, one for joining and one. Yeah. Hopefully we'll get people joining in a second. And then the nightmare side, that was the last 2 weeks, which I spent at a synchrotron doing one of the most obnoxious experiments ever, which I'll go into detail about shortly. It was dealing with liquid ammonia at about minus, well, liquefies about minus 30, and I was taking it down to about minus 60, that sort of thing. Where it's debatable which one's actually more dangerous at that sort of temperature, whether it's just the temperature where it burns you or the chemical corrosiveness of the stuff. Let me see if I can get the chat up here. One of these days, I mean, I've noticed that everyone started sort of streaming and doing stuff these days. I mean, first of all, I take a look at all of the streams. They just seem to be space fillers. And secondly, I just don't have the time to do that sort of thing. Not many people have actually joined. Maybe someone could send me a message saying if the actual link to join the Hangout is working. It should be good, but yeah. And so send me a message saying if the actual link to join the Hangout is actually working at the moment. So I'm not getting any messages at all. Let me out. There's a group chat. That's why. Jesus. Where the hell's? Right. I know why. Just bear with me for 1 second. Okay, so I'm gonna guess. Hey there, folks. So can any of you actually join the Hangout, or are you just here to watch? Because usually people like to join and have a chat. And at the moment, no one's doing that. So I'm just curious as to the links actually working. So I can actually join here. Follows. Watch. Okay. In which case, yeah, I'll tell you about the last 2 weeks, because that was actually interesting. We were doing an experiment with ammonia microjets. Now, liquid ammonia, it's remarkably similar to water in almost every way, except it's very cold and it stinks like hell. Stings and stinks. Hey, finally, Erwin. Hey there. So getting a liquid water microjet, it's not too bad. We're talking something that is about 20 microns in diameter. So it's about the thickness of a human hair. And the reason you need that is because you're then going to spray that microjet into a vacuum. And it turns out if you get them going fast enough, they don't nebulize and they don't freeze, which is good because that means that you can then do experiments on liquids in a vacuum, which is something that's usually quite tricky to do. What they're interested in, for me, I was just here on the supply side for this one. They wanted to zap it with an X-ray beam, which actually then knocks out loads of electrons. And from the electrons that you knock out, the setup is just mind-blowing. So you've got a jet up at the top, and the 20 micron jet comes all the way down. And then you've got an X-ray beam coming in from the front, and that's got to hit this jet about the size of a hair. And then within 0.5 millimeter of that, there is this big cone-shaped thing. Now, the reason it's a cone-shaped thing is because the electrons that come off the jet, they get moderated. They bounce around in the very low pressure gas that's there. So you want to get rid of all of that. This little hole. So once they go through, it's actually a really high vacuum on the other side. So you've got all these things pumping like hell on the other side, and the electrons go through there, and then you put them into a magnetic field, and they sort of spin around, and then they hit the detector. And yeah, so you've got to start. The problem is that the jets, the nozzles block incredibly easily. So you then got this problem of how do we actually unblock this liquid ammonia? And the way that you eventually do it is you just get a syringe, you sort of jam it on the end of the nozzle, and you push liquid back up into the nozzle and hope that that unblocks it. And it's just a horrendous experiment to do because eventually it sort of fills up this chamber. First of all, your hands are inside a vacuum chamber, so you're working on really fiddly stuff. It stings your eyes like crazy. It turns out these jets are so small that you really can't see them. So the only way you can really tell that they're there is you move your fingers back and forth in front of them. And if it stings, then you can feel the microjet. You need really good eyes to see it because it's the closest you can get your head is about this sort of distance. And if you get the light on it right, you can just about see them. Anyway, so other than that, it was a great success. Why people would be interested in the photoelectron spectrum of ammonia, it's not actually that interesting, but ammonia has this really weird property where you can dissolve metals into them. And it's almost unique in this property, as far as I know, that you're essentially alloying ammonia with a metal. You know, that's these alkali metal ammonia solutions. And they maintain almost all the properties of a metal, even though you're dissolving what is essentially a non-metal in them. And there's really just nothing else quite like it that I know of in the rest of science. And that's very interesting. And then it turns out if you actually dilute it even more, it becomes more a solution of metal ions and the solvated electrons in liquid ammonia. And that's also kind of interesting because you've just got sort of electrons floating around there in solution, which, so just out of interest, can anyone actually say something? Just someone else say something. I've been monologuing here like I'm a villain waiting to be taken down.
Well,
there we go. I hear someone unmuted their mic for a second.
I just want to say I'm just starstruck that I actually made it into the Hangout for once. So that's why I'm not saying anything.
Hang on, say that again. It was really quiet.
Oh, sorry, my phone is on the table. I was just saying that I'm personally just starstruck that I even made it into this Hangout. Usually, it's already filled by the time I notice the link.
Oh, cool.
Big fan. You're awesome.
Thank you. So, yeah, that was the last 2 weeks. So, and the really horrible thing is the beam time is usually set up such that you work either days or nights and you get 12-hour shifts. And the really horrible bit is when you go from working day to night because there's like 12, it's like 12 hours of jet lag in the middle of this experiment, which was horrible. But then, has anyone actually seen Deadpool 2 yet?
Ask him if he received the email with the pictures from.
Okay, Agnes, I think you're getting the audio both from playing the stream and being in it. But anyway, if anyone's not actually seen Deadpool 2 yet, this is almost the first time I've ever done this, but I would recommend going and seeing Deadpool 2. It's an absolutely hilarious film.
I haven't even seen Deadpool 1 yet, so I got to see both of them.
Yeah. So Deadpool 1 was this weird surprise success, I think, for the studio that no one really wanted to make it. And it's only because some of the footage got leaked that they were eventually sort of just pressured by the fans into releasing it. And it just broke the mold completely on the superhero films in that all of a sudden it was an 18 plus superhero movie, which is something you just never had before. And that allowed them to do a lot of things that just, I mean, most of the superhero movies are cookie cutter, straight out of the machine. Good guy, bad guy, both are almost exactly the same. So at the end, you get good Iron Man versus bad Iron Man, or good Hulk versus bad Hulk, or good Ant-Man versus bad Ant-Man, and the such like. Yeah, Deadpool just doesn't do any of that. It's completely different, and if for that alone, it's great. Yeah, I mean, for me, I thought Deadpool 2 was much better than Deadpool 1. I mean, Deadpool 1, I just sort of caught on the plane, thought, well, whatever, that might be interesting, and it was good. It was it was different, but Deadpool 2 is just a roller coaster laughing. Strongly recommended. No spoilers.
Sounds good. I'll definitely check it out. I'm kind of waiting for it to pop up on Netflix or one of those.
Yeah. I mean, normally I never go to the cinema, but for some strange reason, this week I've been twice. But before then, I can go back years before I actually went to the cinema because, I mean, I guess I'm kind of like you. You know, you just pick them up at home sometime.
Was it Deadpool 2 both times?
Sorry?
Was it Deadpool 2 both times that you went to the cinema this week?
No, although I would actually go and see Deadpool again. It's that good of a film. The first time was Avengers Infinity War, which is also a very good movie, very long, and it'll make no sense to you unless you've seen a lot of the other Marvel movies. And again, the ending is just, no spoilers, but the ending is just something you've never seen before in one of these movies. It's sort of a mold breaker like that. And for me, something new is it's fantastic. You just get bored of good man versus bad man, and the bad guy has very simple motivations. Here, it's more complex on a lot of levels. Although it must be said, there's a lot of very formulaic superhero action in it. But And unless you've seen all the other Marvel movies, especially the Thor ones, it'll be very cryptic. We actually had someone with us who hadn't seen a lot of these, and they were completely lost for the whole movie. And it's a long movie as well. It's like 2.5 hours long or something.
Did you like Thor Ragnarok?
So it picks up almost directly after Thor Ragnarok for Avengers Infinity War.
But did you like that movie, Thor Ragnarok, or you did not?
To be honest, I only caught clips of Thor Ragnarok. Never actually got to see the whole thing, but it looked fun. It looked very well produced. But I don't know. I didn't see the whole movie. But again, it looked like a good movie. Let's see if I can get some more speak power out of all of this. Yeah, so what's next yeah, next on the movie making, I think is going to be busting the zero mass water, I think it was. Did any of you see the zero mass water? It got covered on, it was one of these YouTube series where you sort of mythbustery type thing, apart from it's meant to be pro science. And the zero mass water, you just do the simple calculations. They reckon it's $2,500 per installation. And it makes a whopping 5 liters of water from the air per day. You don't have to think about it long. For it's going to be a long time before you, yeah, even assuming it works as advertised, which it won't. Because does anyone remember the other free water from the air things that I had a go at?
The water seer? Was it something else?
Water seer, and there was Fontus as well.
The bottle.
Yeah.
It was that bottle too.
You should actually go and check out their Indiegogo page. It's hilarious. People are starting to realize that, hang on, it's been 2-3 years, and all that happens is every 3 months they say that we're gearing up for production. And yeah, I think people might be beginning to realize this thing's never going to appear.
So could you say something about the Hyperloop also then? I know you've
right. So the problem with the Hyperloop isn't that it's not possible at all. It's just it's like putting 3 handles on a cup and then making it out of solid gold. In principle, you could do it. It's just it would be really impractical and expensive. The key thing being that building huge metal tubes is just going to be obscenely expensive. And then to put them under vacuum, I mean, I spent most of the last 2 weeks dealing with what would normally be called a large vacuum chamber. And even the shitty pumps that the roughing pumps that we were using on this big vacuum chamber we looked them up, they were $3,000 secondhand, about $10,000 new. And this is for a vacuum chamber you can just about get your hands inside. Although there was other stuff in there as well, but it would be obscenely. In fact, I can't remember. I might have mentioned this last week. Last hangout. Sorry. I'm going to put out a fake version of the Hyperloop called the Scramloop. Because the reason that the Hyperloop can't go so fast is something called the Kresdal limit, which is, if you're going through a tube, the air piles up and slows you down. Not that any of this really matters for any of the Hyperloops that have been designed yet, because none of them go anywhere near fast enough. And this limit kicks in around the speed of sound. But the thing is, there is something called a scramjet. And the way that that works is it moves extremely fast, and it uses the air that's compressed on the front to, yeah, there we go. Someone knows what I'm talking about. Yeah, and so scramjets, they just go very fast, and they use that compression in front of the aircraft to compress air, then burn it. And with these, you can get up to about Mach 10, give or take. They have to fly very fast because the air has to be very thin. Yeah, so they fly way up in the atmosphere. So of course, if you were to put one of those in your Hyperloop track, you could go 10 times as fast. It's all complete bullshit, of course. Scramjets are borderline viable technology even as we speak. In that,
but if the Hyperloop has proved anything, you can get a whole bunch of funding to go try and build it in the desert.
So that, yeah. So I was just going to do one of these sort of spoof videos, 10 times faster than the Hyperloop at 1/10 of the cost. Because the nice thing about scramjets, other than scramjets are exceptionally hard to make because all the components work at the aerodynamics at these sort of transonic speeds are difficult. And that's in the atmosphere. If you were to try and do this in a tube, of course, a low pressure tube like the Hyperloop, it would be cuckoo banana cakes.
At testing scramjets,
but yeah, you basically need rockets to get them up to speed for them to work. And I think the only reason people are sort of researching them is essentially a budget intercontinental ballistic missile type thing that basically they skim across the upper atmosphere, but they don't lose speed because you're generating some thrust through the scramjet. But yeah, of course, why not run a scramjet in the Hyperloop tube?
Yeah, why not? This
It would be
combustible gas.
Well, there is that, but then of course I've got the perfect answer for that. That will be recycled into biofuel, and because it's not emitted into the atmosphere, it will be carbon neutral.
There you go. Have you heard of Startram?
Startram, is that the electromagnetic? Yeah, but that's right, and it uses it to launch satellites.
Yes, that would probably be the only kind of sensible use of vacuum trains. I mean, the thing is it sensible to build such a thing? Because do we really need it currently? Yeah.
Well, I mean, it's the construction costs are just obscene with something like the Hyperloop. To the point where I'm even sort of fairly doubtful what sort of vacuum they have on some of these things, because what's the point of vacuuming down a tube like that if you're going to get no tangible gain from having it? If you're not going fast enough for the air resistance anyway, what's the point of vacuuming down the tube?
Also, the linear drag shouldn't change, should it? Because linear drag only changes once you get down to the mean free path being approximately your tube size. Because it counts out.
Again?
Well, it has been an experiment a long time ago, but when you actually put a pendulum in just a vacuum chamber, it doesn't swing for much longer unless you get down to pressures where your mean free path becomes the size of the vacuum chamber.
Really?
Yeah, because
I've just ordered a vacuum oven this week. I'm tempted to try that because
the thing is, there are less particles, but the particles can move away
faster.
Yeah, well, they can move away from your pendulum a lot quicker, so they can transfer the momentum much faster. But it's only the linear drag; it's not the quadratic drag. Drag.
So that's the same reason that vacuum flasks need. If you get a partial vacuum on a vacuum flask, it's almost as bad as having No vacuum. Because even though you've got fewer particles in there, they on average move further. So they transfer heat almost as well, which is basically transferring momentum, of course.
Yeah.
But yeah, no, I hadn't actually thought about that. That's actually quite an interesting experiment. What sort of vacuum do you say you had to get down to? So like sub-millibar?
Yeah, well, you need your mean free path being approximately your vacuum chamber size, so...
Oh, that's huge. That's no, God, no.
So it needs to be like...
that's really low.
A few Pascal.
Yeah. Yeah, that's fractions of a millibar.
Well, time to buy a turbomolecular pump. These things just creep me out, though.
Sorry?
Turbomolecular pumps, they just scare me. Like 2 megawatts, 2 megajoules, and such a tiny package. No, thank you.
So this is the thing. This synchrotron I was at, the instrument was absolutely covered with turbo pumps, including one very large one. Because of course, with turbo pumps, the only time you're actually really worried is where all the momentum is. There's that big spinning disc. If that breaks up, that being said, because when I was young, they had a reputation exploding because they have huge amounts of energy in them.
Yeah, a couple of megajoules. It's pretty crazy.
Yeah, I don't know how many bullets that is, but it's quite a lot. But that seems to be a thing of the past. In the this synchrotron, it had loads of them. I even looked it up afterwards to see if there was any pictures of exploded turbo pumps, and it looks like things have kind of changed in that.
Yeah, I think it's two things. First of all, they use magnetic bearings almost exclusively now. So there's no real wear, and with the ones that do, well, you have controllers with them, and they're pretty clever controllers.
They stop.
When something goes wrong. But still, if you just open a valve and put the entire atmosphere on there, they're still going to explode.
We did that twice with this big turbo pump, and we've entered the vacuum chamber. Yeah, there'd been miscommunications. They weren't meant to have turned the turbo pump on. And we had to get back into the vacuum chamber. But the thing is, you hear it very quickly. Turbo pumps lets you know. Apparently, this thing had been abused for decades. Well, not decades, about a decade. It was almost the only original piece of kit that was left. And yeah, they pumped all sorts of nasty things through this turbo pump, but it was still going. But yeah, I mean, for me, I feel uncomfortable around those things.
Yeah, especially because you're often like in the plane of where things would go if something goes wrong.
and there's just going to be this large boom, and you're going to end up with turbo pump blades in you.
Yeah.
Did you see that this week someone was killed for the first time by an electronic cigarette exploding?
I have not, but it makes sense. I mean, lithium polymer batteries.
Apparently, they found part of it in his skull, but it looked to me like what killed him was the house burning down.
I see.
So,
okay, would that guy earn a Darwin Award, or would he not earn a Darwin Award because most likely he's going to be followed by others?
Well, what I want to know is, does he get it put on his gravestone that, the first man ever to be killed by an electronic cigarette?
How the hell did it explode? Lithium batteries don't explode; they just burn.
Yeah, exactly. Just pop.
You get them in a nice. Actually, the majority of the problem with them is they do burn, but they can also get a fairly decent pop off them. Especially if you're going to actually, this is the only way you can get sort of flying metal fragments off them that I can think of. Is the liquid basically inside them boils, and if they're in a metal tube, a little pipe bomb, but there's not much energy in that.
Oh, hang on, they don't use lithium polymer, do they? They use lithium iron phosphide, don't they? 18650 cells.
Yeah, they
and
usually
they are steel cased.
But even then, if that thing decided to let everything it had in it go all at once, it would swell the tube because it's usually, like you say, boiling it and raising pressure. It's not an instant pressure.
And they have valves, don't they, to not explode?
Sense, yeah, weak spots that'll go like capacitors. But I guess if he sealed it inside of a metal tube of the body of the grid itself, but even then, it should swell that thing up. So if he keeps running it, then the metal tube of it's swelling up, then that would be a whole different problem.
But I mean, smoking kills tens of thousands of people per year. As far as I know, the electronic cigarettes are more or less, other than the exploding ones, completely safe.
Yeah, it's just glycerin and water. That's it.
Yeah.
There's 2 or 3 compounds. The glycerin and water one is one of the more benign ones, so it's used more often now, but there are a couple of others. I mean, they're as safe as breathing not air into your lungs is, but at the same time, it's much safer than actually breathing in combusting materials.
Yeah, and the thing is, they're water soluble, the things you breathe in there.
Yeah.
But have you seen how much smoke those things can make? When people are on the nebulizers, they start blowing out these huge clouds of stuff.
There's this one guy who built a 1.5 kilowatt one. It's just stupid.
1.5 kilowatts?
Yeah.
You could almost run a kettle off that.
He used like lithium polymer, like the RC batteries. And they do that easily, right? So.
Well, there was one guy a couple of years ago that powered his off of a car battery. There's another guy who used one of those nightclub foggers. He put the e-juice in that and then had a big long cardboard tube and used that. That one was pretty funny to watch.
I mean, they're the same thing, essentially.
So I've never smoked or done the electronic cigarette thing, but I always wanted to blow smoke rings.
Well, with the electronic cigarettes, you can literally just use water and glycerin. I'm not really a fan of it myself, but it seems fairly okay. I mean, your body produces glycerin, so...
Try it.
Yeah.
Try to make the biggest one on camera.
I'm wondering if you can do the same thing as you can do with bubbles. You get those sort of absolutely giant bubbles. What's the biggest... Actually, someone must have done it. I'm absolutely certain that someone's done the biggest smoke ring. That's got to be a world record or something.
Oh yeah, there is some German university. They built like a huge of these ring cannons and then filled it with smoke. Well, with mist.
Vortex cannon.
Exactly.
Yeah, those are fun in that you basically need the smoke in them to make them visible. But they've got no real. I don't think they have any power to them. They dissipate really quickly. Yeah.
Well, the loop is quite what's it called? Toroidal vortex. They are pretty stable, like mathematically, but yeah, in reality, a couple of seconds.
I have a friend. If you have enough power into him, a friend basically used a 55-gallon drum and some fireworks, and he could blow shingles off of a barn half a field away.
That's pretty neat.
What's the speed those things go at?
I would say depends, but at least a couple meters per second.
I mean, I know the slow ones that you're talking about. I mean, you can get these kids' toys that basically shoot the vortices, but doing it with explosives and a steel drum, that might actually be interesting. You know, do they move faster, or I mean, it's almost a sort of shaped charge of air.
Basically, that's what it was.
Yeah.
I don't know if it would go any faster.
I don't know. I'd have to look into that, but yeah.
Where's everyone today? Usually we're like...
I don't know. It seems quiet.
Any advancements with your research?
Oh, right. Yeah. So beyond the microjet thing, I'm still doing things like distilling heavy water for mice to taste test.
Ooh.
I'm still doing the taste testing of heavy water, which in principle shouldn't taste any different from regular water, but it does. It tastes sweet. We sort of narrowed it down now to a single taste receptor, which is, well, I'm not quite sure why we wanted to do this, but actually I do, in kind of. Do you know the Uri Miller experiments?
Not really.
He's the guy who put hydrogen, nitrogen, oxygen in a glass container and heated it, boiled it, and passed electricity through it, and they got the basic building blocks of life. You know, some amino acids, fragments of. And he did that about 100 years ago. He also discovered deuterium, and was the first guy to actually taste D2O, and said that it didn't taste of anything. We reckon it does. Tastes sweet.
It's extremely slight, isn't it?
It's pretty pronounced. It's so actually the benchmarking. It's about 1/10 as sweet as Coke, and Coke's pretty obnoxiously sweet stuff. So
I'm just drinking like pure water, like proper pure water. I was pretty surprised how different it is to tap water.
You've actually tried it?
Yeah, it's not even distilled. Around the lab we have like it's not really reverse osmosis. It has like two membranes and then electrodes, and it outputs water with like 13 megaohm centimeters. So essentially pure water.
Pure water, very pure. Yeah.
So pure that it's in like a Teflon thingy and stuff like that. You can't even leave it in air because it absorbs CO2. It doesn't taste of anything at all. Sorry,
what is this?
It's just pure water, like literally the purest you can do. And they like benchmark it by just measuring the resistivity. And at some point you just all the ions you have is just H2 and H2O, H2 and H plus and O2 minus, OH minus. Got that. It doesn't have any taste at all. It tastes weirdly of nothing. Like you have the feeling, but that's it. It's very odd. Yeah.
So,
like that ultra quiet room with all the tiny cones, where you can't hear anything and it's freaking creepy.
Yeah, I guess. Yeah.
So I heard that about the sensory deprivation thing, that you go and sit in these tanks where there's no noise and you've got almost no sensation, and sort of 15 minutes feels like hours. You know, you lose very quickly the feeling of the passage of time. And part of me wouldn't mind trying that, but part of me just doesn't want to be locked in there. You know? So meanwhile, in the world outside, I don't know, everyone gets killed by a virus or something. Just being left in one of those sensory deprivation tanks. Ugh.
Working in proper anechoic chambers was enough sensory deprivation for me. We had a couple of big ones that we did RF testing in, and walking in there and not being able to hear your voice reflect off of things around you was a very odd sensation. And that was just one sense.
So that's where the sound is just killed completely by the room.
Yep. The rooms with those big cones on the edge. So they have ones for sound, so have them for RF, which also happens to kill sound. So the ones we were working in were they were probably a meter long, a meter deep cones. The cone stuck out at probably a meter, a little bit more than that from the wall. And so because the foam turns any RF energy into heat to kill it, to make it go away, it also did that with sound on this foam. So the walls absorbed all sound.
Yeah.
So you're talking to somebody and you're hearing their voice directly from them with zero reflections, and they sound very different. When you talk to someone else, you're only hearing your voice through your head, not from other reflections around. It sounds very different. So that's the closest to full sensory deprivation I care to get.
What was the floor made of?
In the ones we were in, it was just like heavy rubber tiles. So the floor itself was fairly echoey, but it would echo away from you and then go into the wall and.
But the foam itself is, I guess, it's like something slightly conductive or something like that.
It's not a semiconductor, but it is like a carbon impregnated expanded foam. So they're real light, but when they vibrate due to the heating from the RF or the sound of your voice, it turns it to heat and turns the energy to heat and sends it away. So it doesn't reflect back.
So what was this room for? Absorbing the radio frequencies?
Radio testing. The project I was working on, do you know the company name GoGo? They do internet on airplanes?
No, but I do know.
Okay. I worked for Aircell, which was their business division. I don't recommend working for GoGo, company reasons, but I was working in their test for their unit that would go on the airplane that was basically a 2-watt cellular phone that would connect down to cell towers to provide internet on airplanes. And we were working on business jets. So it was the first internet on airplanes before they had the KU satellite stuff they have now. This was probably 6-7 years ago, and the product had been out for a couple of years. We had to go take these units and put them in the RF chamber along with their antennas and everything to make sure we could pass all of the FCC and FAA radio transmission requirements. And, measured radio transmission requirements. So when we put these things on the airplanes, they wouldn't knock airplanes out of the sky.
Yeah, I was always kind of skeptical about, forever they had this thing that turn off all your electrical devices before we take off. And
that's nothing obviously avionics. It has everything to do. The rules on the airplanes about turn your devices off and put them away has nothing to do with the electronics in the airplane, because they're super heavy shielded, multiple redundant systems, all that kind of stuff. You could have a 1,000-watt transmitter in your lap inside the airplane tube, and it won't affect the avionics. In fact, they still keep some of the old, they keep one altimeter and airspeed indicator that are purely air pressure driven, no electronics whatsoever in planes. Most of that is they want you to put your cell phone away. So number one, you'll listen to their safety briefing, and number two, most accidents happen during landing and takeoff, right? When the plane is near the ground but still flying, most critical time. If something happens during that time, they don't want everybody to have their cell phones out, and now they've got a whole bunch of shrapnel flying through the aircraft tube.
But they always say it's because it interferes with the plane's instruments, or could interfere with the plane's instruments.
That's because people won't question that answer. They will question I can hang on to it through a crash. So since people don't know electronics very well, they put them away. Now that people are figuring this out, they're starting to say, okay, you can keep your cell phone out as long as it's in your pocket, but laptops have to be put away. But it has nothing to do with the radio frequency. It has everything to do with making sure things don't fly around the cabin.
Yeah, so when I was a kid in England, we used to have this thing called the TV detector van, which claimed it could detect people with... Right, in England, you've got to pay a TV license if you've got a TV. In principle, to pay for the public broadcasting. Why it's ring-fenced like that, I'm not quite sure. It's an ancient thing of history. But actually, I've heard that in Germany you had the detector vans.
Oh, it's crazy, yeah. with the TV license, just like, well, from a political point of view, it's so stupid. Nobody watches it. They take in over $3 billion a year, and it's a private company. It's crazy. But for the detector bans, I'm not too sure about. I know that my father got in trouble because his, well, it was like a loop antenna. The electronics, actually, it wasn't his fault. The electronics had some problems and started sounding, or essentially echoing. And that would interfere with the emergency radio calls. So they found that pretty quickly.
Yeah.
It's just ran around with Yagi antennas.
If you've got a transmission, there's used a bit of triangulation, and it's fairly simple. But yeah, I mean, the whole TV detector thing was just bullshit. I mean, it's not. This is no.
It's hard to do. Here in the States, they had it with radar detectors. Some states don't allow like radar detectors in your car to tell if the cops the police are scanning radar.
Yeah.
What it is because the TV has a local oscillator in it to be able to lock on to the transmission, because it's usually super heterodyne, so it's got its own oscillator inside. It leaks back out of the antenna if the antenna is halfway decently matched. So they put a super they put a super sensitive receiver around the known LO for the TV, so it can detect the TV stations, and they can go around. And basically, if you have an antenna, you have a little bit of LO leaking out, they can detect that and see if you have a TV. It only works while the TV's on, but it happens with radar detectors too. And so you'll have, basically, they try and build it into the radar speed devices for the cops. They'll try and put that LO detector in there also. They have to be super sensitive. They're easy to interfere with. It's hard to do, but it's possible.
So this I could maybe believe. It's essentially an echo on the.
No.
No.
So a TV has a super heterodyne radio, meaning it takes its own internal oscillator, mixes that with the transmission to bring it down to a lower frequency so the electronics can process it. What they're detecting is your local oscillator inside of your TV that's used for tuning leaking back out of the TV. So your TV is essentially a very, very, very weak transmitter.
Yeah, that was the problem back then, because my father works in a hospital, so he had this weak transmitter right in the hospital, which didn't go too well with the
authorities.
Yeah.
But I mean, with the BBC, there was certainly a decent reason for having it early on. Now, not so much. And I know how it works in Germany, but the BBC is just incredibly prudish.
Yeah.
I still like some of the stuff they do. Radio 4 is pretty decent, but it's essentially the world service. So it's broadcast all over the world. But I mean, and they do some interesting dramas. But I mean, none of this I watch. I know people like it, but is there really any need to have a television tax anymore?
Well, in general, I think it's not generally a bad idea. But in Germany, the amount you pay for what you get back is just disproportionate. I would have to look at that. I haven't lived in Germany for quite some time, but it's more than like 100 euros a year you pay, which is quite a lot.
That's about the same for the BBC.
Oh, okay. And you get, I think they produce like 60 channels, 20 of which are actually different, because they've got for like every bit of Germany their own one, even though it's all, I don't know, ARD or something like that. Mostly watched by really old people. Not only, some of them are pretty good.
Well, television's pretty antiquated now.
I think that's a problem. They do put some of that money in like a YouTube channel, which is actually pretty good. It's just they take in $3 billion for what is essentially 20 odd channels. It just seems a bit wrong.
Yeah. I'm just trying to put that into YouTube terms.
Yeah.
That's a lot of billions for. Yeah, I mean, because a lot of the time they just sort of loop stuff. Yeah.
Yeah, or it translates stuff from
reruns,
like English into German.
Yeah.
So,
yeah, go.
Oh, your gamma spectrometer.
Yeah.
Is that a scintillator?
Yeah.
Okay. Because I'm looking at a couple currently. Yeah.
So there's a guy in Russia who looks like he makes them. They're not exactly, how would I say, consumer grade electronics or anything, but you plug them into USB and you get some off the shelf software, and it'll give you a gamma ray spectrum. You've got to calibrate it yourself, which is a pain in the ass, but other than that, they're relatively cheap. They're a few $100s, that sort of thing.
That's pretty good.
Yeah, you compare it to a commercial product, and you can add a zero on the end of that.
Yeah, exactly.
So all of a sudden, the way you usually do it is you get a cesium-137 emitter, which is actually quite easy. They're sold in spark gaps. Now, most of the spark gaps you get on eBay will tell you that, oh no, all the cesium's decayed away and you don't get a gamma ray spectrum of it. But that's just, I think, something that they have to say to get around selling radioactive stuff on eBay. Because
well, there's quite a lot of radioactive stuff on eBay, though. It's
but what cesium-137's a touchy one because it's
yeah, true.
Anyway, all you're after is the right. It's a powerful half mega electron volt emitter. So you get a nice spike to calibrate the spectrum on, and then it costs like $10 or something. The 137 source.
Yeah, well,
like it's 30 years. Yeah,
something.
Yeah, it's yeah. I mean, if you live near a radioactive mine of some description, and there's plenty of it around, I mean, it's quite fun to kind of find stuff.
Well, the thing is that I'm going to Chernobyl for like 2 days, and yeah, I can't take ground probes, so I thought I'd just test it right there. Yeah,
you can't take
ground probes in Chernobyl. They don't allow you to take probes with you.
Really?
Yeah. So
I mean, like your own Geiger counter.
No. Like take probes off the ground and then take the probes with you, and like as in like samples. Sorry, yeah, German. Sorry.
Yeah. Samples.
Samples is a better word.
That makes sense. Otherwise, you'll have a cesium-137 source for life.
Apparently, yeah, but it's not that strong, is it? So
apparently, if you're poking around, you can still find sort of particles of core, which is radioactive. Yeah, but I mean, we're talking small particles, but it's radioactive like hell. And you're all right. Once you get 10 centimeters away from it, you can barely detect it. But yeah, it's a small particle of something that's screamingly radioactive.
I might just wipe down the car afterwards or something, and there you go.
Well, I mean, this is the thing, though. If you were to take something like that, how would anyone know that you've taken it? I mean,
yeah, true.
Well, they wouldn't until they go through a border crossing that has detectors.
I'm really skeptical about those too, because
I want to test them, but I don't really want to be at a border crossing and get caught testing them.
This is true, but I still wonder how those things work. In that, the things that you make bombs out of, which is uranium and plutonium, are alpha emitters, which is absorbed very easily.
Might look for
there's probably some sort of secondary gammas that come off it. Once you've got a spectrometer on it, of course, it becomes very easy. You just look for the characteristic energy photons. But the thing is, you need a lot of uranium to do that. I've traveled several times with thorianated welding rods, and no one batted an eyelid there. One of these days, I'll summon up the courage to try taking. Actually, no. I've taken some of those uranium samples. I split those up and put some of them in my hand baggage, and no one raised it. No one batted an eyelid. And if you take a look at people who've tried shipping radioactive stuff on eBay, because a lot of the radioactive crystals of uranium, they're very radioactive, but they're also you can sell them as geological samples. And people sort of say that, as long as you sort of wrap them up, they don't seem to go crazy about it.
I took like 3 kilograms of dirt from Cape Verde, and they didn't ask, so it should be fine.
I mean,
yeah.
You did the videos here in Colorado, which is where I'm from, where you were going around playing with the uranium rocks. It's tempting to load a couple of kilograms of those into the back of the car when I go to Canada here in a couple of weeks through the border crossing and see what happens. It's a rock.
Yeah. But if you ever get down there, that drive north from Yerevan is incredible. It's a drive through the middle of nowhere, but you sort of start off in this little canyon, then it winds out into not quite Grand Canyon type territory, but there's absolutely nothing there. It's a road to nowhere, but it's an amazing road to nowhere.
I haven't done that one yet, but my brother used to he went to college down in Durango, and we live up in Denver. And so we do the Highway 285 that goes right down through the middle of the mountains, and you hit the big valley plains and then go over the crazy winter passes and down there. So done that one a few times.
Yeah, anywhere around Durango, is awesome.
Yep.
Yeah.
But yeah, I will probably just wipe the dust off the car once we leave the exclusion zone, and it's good enough of a sample.
Actually, yeah, so as far as I know, almost the only thing left of the Chernobyl radiation is the cesium.
Yeah, it's cesium and strontium, isn't it?
But the strontium, I don't know what it is, but because you expect cesium and strontium to be there in roughly equal portions, but when you check out these graphs of what's left of the Chernobyl radiation, it looks like it's just the cesium. Now, I don't know whether that's just all the strontium's been, sort of sequestered in some form or another into, I don't know, strontium carbonate or something that's just doesn't move around anymore, and therefore, cesium is the only thing that's mobile.
I thought strontium, the strontium-90 was so nasty because your body thought it looked a lot like iodine, and so it would sequester it in place of iodine.
It looks like calcium, and it gets into your bones.
Okay.
And that's why it's really nasty. But it looks, it doesn't stay soluble for long. It precipitates out like calcium. There's not, all right, I suppose you can get hard water areas, but
Wikipedia says it's less likely because it's much less volatile, but they don't specify why.
Yeah. And that's the thing. Yeah, I mean, cesium is just like sodium, so it dissolves very easily, moves around very easily, but it doesn't bioaccumulate in any serious way. Strontium does bioaccumulate, but I don't think it moves. Yeah, once you've had a few weeks or something, and it ends up as essentially an insoluble form which you can't drink.
No, I see. Fair enough.
But I'm guessing about that because I know that when Chernobyl happened, they were very keen to throw away all the sheep's milk. So not all the sheep's milk, all the cow's milk. Well, I think that was iodine. That one.
Well, with the iodine, thankfully, it doesn't stick around that long.
Yeah, I mean it's a year and everything is gone completely.
But it's radioactive for 100 million years. Oh no!
It's crazy.
What happened to that guy? The Dixie Cup guy.
He's still going, and the thing is, he does exactly the same hangout every time. I mean, I've not watched him for a couple of years, but I'm just curious
if he's happy. Fine.
Yeah, but he's completely Fruit Loops conspiracy theory guy. And the bizarre thing was, if I remember rightly, he used to be into scuba diving, and he was the safety inspector for the scuba gear, and that was just kind of scary for me. It's like, would you really want to trust your life to the kit inspected by this guy?
All right, well, you're looking that up. I gotta run, so it's nice talking to all of you, and hop on next time.
See you.
Okay, thanks, Daniel.
Keep up the break and the science videos. I am really interested in that ammonia research you're doing.
I'll try and get something up on that.
If you can. I know there's IP protections and stuff, but...
it's an absolute nightmare with the collaborators because they're from a different era. Until it's been published, you're not going to say anything about any of it. And for me, first of all, no one's really going to be working on the same stuff anyway. So why not do something interesting with it? Yeah, if you make a nice video about it, why not?
Yeah, and it just cements your place as having figured it out first.
Yeah, exactly. I mean, the thing that I keep telling him is, look, I put out the idea of why sodium explodes in water 2 years before we actually did the experiments, and it made absolutely diddly squat difference.
Right.
Are you really worried about someone beating us to solvated electrons in ammonia? Whereas, as far as I know, there isn't anyone else doing work on liquid ammonia in this field anyway, let alone to the point where they can run these jets themselves, which is quite tricky. So yeah, I'll see what I can do. I'll see if I can.
Sounds good. Have a good
Guerrilla
day.
science.
So, the beautiful girl by Dana. Still there? Still going? Yeah, good. Yeah, he's still putting out videos every week by the looks of things. Still on Fukushima. Good God. His last 4 videos spanning a month are all on Fukushima. And they're all about an hour. I don't know, half of them are about an hour long.
Oh,
Well, how can you be putting out an hour-long video on Fukushima? Oh, God. Fukushima, 150 whales washed up in Australia.
I mean, if you really look for things that happen, and you will find them, no matter if something happened before or not, right? Making the connection to Fukushima, that's probably the issue there. Actually, what's going on in Fukushima now anyway? Because with Chernobyl, it's always easy to know.
Sorry?
Well, with Chernobyl, it's always easy to know what's actually going on. Well, new safe confinement, move that over. Now they're actually securing it, sealing it. But what's happening with Fukushima?
All I know is the last I saw, they were just scraping up all the topsoil, putting it into giant sacks, and just leaving it in a big pile. Which there are some advantages to, but it's not really a solution. I mean, eventually, I think it'll just go the way of Chernobyl. That 20 years down the line, all right, people don't go there, becomes a wildlife refuge.
Yeah.
But yeah, they do have an awful lot of nuclear material in those reactors that they've got to get out somehow. I'm not quite sure what their plan is there. But how many years is it since Fukushima now? It's
2011.
5 years?
So. No, 2011,
Yeah, so
7-ish years, I guess.
Yeah. And still, no one's. I mean, that it was billed as being one of the worst nuclear disasters ever, and
not much was released, was there?
No, and what gets washed into the ocean dilutes very quickly. What doesn't dilute very quickly precipitates and just sinks.
Oh, did you see the report with? Oh no, it's 1 microcurie per cubic meter more of cesium-137.
Yeah, I mean, if you can detect them with really sensitive equipment, are you shitting me? I mean, yeah, that guy who just left, he'd been to these places in America where you can get, 50 tons background without even batting an eyelid.
Yeah,
that's just the uranium in the rocks.
Especially with the water, was crazy. Because let's just ignore the 10 kilocuries. No, sorry. It was a becquerel. It was a microbecquerel they measured. Let's just ignore the 10 kilobecquerels you get just from the potassium in salt water. So, yeah.
Yeah. Yeah. Once you're down to banana equivalents, forget about it. I mean.
Yeah, exactly. The YouTube chat asks, was there ever a life-threatening incident during your research?
During my research, I don't think during my research I managed to have some pretty scary experiences when I was a kid. When I say a kid, sort of, I don't know, 15 to 18, that sort of thing, where I did some very imprudent experiments, including one where the idea was I wanted to burn sulfur to make sulfur dioxide. Which is easy enough. You light sulfur and you blow air over it. That's easy, apart from I had this big glass bottle. And the problem was always lighting the sulfur. You've got to get it quite hot before it'll burn, then you can blow the oxygen over it, and it's dead easy. So I'd actually managed to get this thing full of sulfur vapor before I started, and then when I lit it, it exploded. And I got lucky. But yeah, important lessons about prudence were learned that day.
That's something similar with oxyhydrogen. Just build a little cell in a glass. It was a vino bottle, like a vino jar, an upside down one filled with 10% sodium hydroxide. Backflash, lid popped off. Half a liter of sodium hydroxide everywhere in my room. Not that great.
That's, I mean, it's one of those things. Sodium hydroxide, you dip your fingers in it, you wash it off, no big deal.
Yeah.
If you spread all over if the stuff is in contact with anything, it's evil, corrosive stuff.
Yeah, I had to repaint. It's
not a nice cleanup. I mean, eventually it just pulls out carbon dioxide from the air to give you the carbonate. But even at that, the carbonate's pretty alkali stuff as well.
Yeah, and it's like abrasive. So you've got this really fine abrasive stuff everywhere now. It's not too abrasive, but enough to feel it.
Yeah. In terms, actually, there was a pretty decent explosion while we were doing the sodium experiments. Before we'd really worked out what the hell we were doing, we were just sort of chucking the stuff in the water and sort of seeing when it would explode, when it wouldn't. And we'd run out of potassium. Potassium explodes much more easily, but it's more expensive, so we'd run out of the stuff. And we're on to the sodium. Now, sodium rarely explodes, but when it does so really violently. And so we just playing around with small amounts, about 300 milligrams, which is not a big piece of sodium. But it exploded really violently and scared the shit out of all of us, completely destroyed the flask that we were doing it in. and we all took the democratic decision then that it was time to call it a day. And yeah, we'll try this again with smaller amounts tomorrow. And the other one that we tried, which I've still not actually done, I'm still not put up. This was years ago now. Is we would try the explosion in different salt solutions to see if the salts have any effect on the explosion. And yeah, of course they do. Some of them inhibited them, some of them don't. And we also tried it with some oxidants and acids, and maybe expected, maybe not. Hydrochloric acid doesn't explode at all, completely inhibited. Sulfuric acid the same, but it does weird stuff. I put that one up. With nitric acid, it was exceptionally violent. So this was concentrated nitric acid, which has been used as rocket, but it's evil. Nitric acid, sulfuric acid, I'll happily stick my finger in. You wash it off, you're fine. Hydrochloric, even more of a benign thing, even when it's concentrated. Nitric acid, you do that and you'll be screaming in pain within a few seconds.
Just almost orange, and yeah, all the carotene on your fingers, just there you go.
And yeah, so even though this was one of the ones which we'd taken sort of full safety precautions on, we've got the high-speed footage of it somewhere. Actually, I'll see if I can root it out and put it up on the Patreon thing. But when we got the explosion in water, you see the fingers stick out, and that's it. Then you see the expansion of gas. With this, it's bright orange. It's sort of emitting light like crazy.
That's odd.
And it's pretty decent rocket fuel. And after that, it blew all the bungs out of the reactor, and we decided, okay, we're not repeating that experiment.
Fair enough.
We did do it with dilute nitric, and it exploded for that as well, just not as violent. We also did hydrogen peroxide. Hydrogen peroxide at 30% does similar sort of stuff, but as you will well know, if you get concentrated hydrogen peroxide and about 70–80%, the stuff can explode on its own. So we only went up to about 30%, and at 30%, it was getting pretty excited.
Yeah, well, 30% hydrogen peroxide is already sketchy stuff, isn't it?
Quite nasty. Yeah. So we were playing around with the edge there, but we were prudent.
Two more things about that, actually. The transparent thing you get, like the transparent marble you get before it explodes. Do we know what that even is by now?
So we actually did a paper on that, and you'll be it's the second paper that I've had that's got Patreon supporters acknowledged in the acknowledgements. It was published in Angavante about 2 years ago now, I think.
Okay.
And I actually did a video about it, which I'll also I'll put it up after the Hangout. Okay.
Sure.
And it's complicated. It's very complicated. And what it probably is when the metal first lands on the surface and it gets above a certain critical temperature, all sorts of things start dissolving in the metal, in the same way that ammonia dissolves in the metal, but it's got to be hot to do it. And so when you first put the metal in, it develops a blue skin, bright blue skin on the surface. And then that skin vanishes and you get shiny metal, and the shiny metal eventually turns black. And then just before it turns transparent, it goes blue. And it's the same blue that you get for the solvated electron in ammonia. And we measured the spectra of all of these things, and it's fascinating stuff. Yeah.
Is it also nature?
It was Angewandte Chemie, which basically means new chemistry in German, I think. Yeah.
Yeah, okay.
Novel chemistry.
But it's applied chemistry, I think. Yeah.
Applied. Okay, sorry.
No, it's fine.
So yeah, I keep on meaning to make that into a more. So I did a video that went with paper, but I wanted to do one that was more accessible for YouTube. Because otherwise, I was worried that too technical, the video that I made. But I don't know. I'll put it up, and yeah, if you like it.
I found it. I found the paper. Yep. Good.
So there'll be I think there's a link in the paper to the video, I think.
Yeah, we'll have a look at it later. It's fine.
Oh.
Yeah, I think I found it. Perfect. Oh, yeah. I'll have to log in with like university.
But it's got some really cool footage. Yeah. And that was also quite an interesting one. There's part of that where we take a drop of sodium potassium alloy and burn it in steam.
Ooh.
And for me, I just couldn't believe what I was seeing. It just sort of burns away to nothing in steam.
Doesn't it leave like some hydroxides or something like that?
No, I mean, there's enough energy in it to completely vaporize everything.
Oh, okay, fair enough. So
which I just wasn't expecting.
But the drop itself, the clear one, is it more sodium hydroxide or alkaline hydroxide or metal?
My reckoning is it's mostly sodium oxide.
Oxides, okay.
But sodium, it's difficult to tell. I mean, I tried to capture one of those drops, but again, that's a thoroughly obnoxious experiment to do, because just like concentrated sodium hydroxide is quite nasty. That drop is, first of all, when it explodes, it's at 300 degrees. It's pure sodium hydroxide or sodium oxide. It doesn't really matter which. It's corrosive as hell, burns like hell. And we still don't know why that one explodes.
It might just be Leidenfrost.
So it is certainly Leidenfrost is involved in there. But there was this guy called the Backyard Chemist. He did this thing where he dropped sodium chloride.
Yeah, that was my next question. Why the salt? It shouldn't even react, should it? It's thermodynamically not favorable.
Yeah, no. So I keep on meaning to do some work on that as well. Now that I've actually got a decent high-speed camera and all the equipment needed to heat salts. The thing is, what he was doing was very impressive, but if you want to narrow down what's causing it, you need to get right in and close on the explosion. Now, it turns out we actually filmed the sodium hydroxide explosion or the sodium oxide explosion at about 30,000 frames per second, and it just looks like it just explodes. But what I suspect is happening is it's a similar thing to the Coulombic explosion. It's to do with the surface propensity of ions, because you've only got to overcome a relatively weak force of surface tension to get a Coulombic explosion on these things, right? Yeah. And so if the chloride ions prefer being in water, which they do, much more than the sodium ones, then the first thing that you get is what you call a zeta potential. It's basically all the negative ions are on the bottom, all the positive ones behind it. And if that happens quickly enough, you can get a lateral repulsion on it, which is what you need for this explosion. Because the thing is, with the Backyard Chemist stuff, it's clear again, there's this erratic nature to it. Sometimes it happens, sometimes it doesn't.
Yeah, and there's like a really clear like difference between just steam explosion and then there's this essentially supersonic detonation. It was probably not a good word for it, but it's yeah, there's a big difference between them, and it's not
far off a detonation in that, there's it's not a detonation, but it's a hell of a lot faster than a steam explosion.
Yeah, exactly. There's the speed difference, which is just odd.
So it's, my reckoning is it's about an order of magnitude faster than a steam explosion, which is more or less what we got with the alkali metals. Apart from with those, it was very easy to see what was going on because the metal, you can see the spikes coming out of the metal. Much more tricky to do that if you're dealing with two clear, colorless liquids. It turns out I actually do know there's an experiment that would be able to tell you, and it involves, again, a synchrotron. You basically need a very intense X-ray source and to be able to control one of these explosions, because then there's a very big contrast between the sodium chloride solution, which has lots of chloride ions in it, so there's lots of electrons. It is dark. If you take an X-ray picture of it, and the water, which doesn't contain many heavy nuclei, so it's relatively light. Then you need enough. Then you need enough X-ray flux to do high-speed photography with that, and you can do that at some of these synchrotrons. I've seen them do high-speed imaging of explosions before, but this one would be an absolute nightmare to do. I mean, first of all, you've got to be able to do the explosions reproducibly, which is it's tough. Yeah, you've got to convince them to play ball.
Yeah.
Hi.
Oh, hey. You're still alive then after all your rocket stuff?
Yeah.
Hey.
With the synchrotron, I mean, there are a couple ones which you can literally just rent booths at, and then get all the light you want.
If you're talking at the larger synchrotrons, the only way to sensibly do that is to write a proposal and get beam time awarded. Those things are obscenely expensive.
Really?
Yeah, like
no, I was thinking
like a day or something.
Oh yeah, okay, fair enough. Yeah, because I was thinking like diamond light source or something like that.
So Diamond, the UK synchrotron?
I think so. Yeah, it's quite close here. Yeah.
Yeah. I left England before it was built.
Fair enough.
And with a lot of these things, it seemed that people were looking for reasons to build them. Not that they really needed them. It's just they wanted one for the UK, which was Diamond, or France, which was Soleil, or Germany, which was Bessie. I don't know. It seems there's more synchrotrons than there's things to do with them.
Fair enough.
But, I don't know. People seem to like building them. So, yeah.
They're kind of cool. So, what should you say?
They're impressive machines.
They're not really that useful if they're not used.
Yeah. So, are you the guy who was trying to do lithium at 10 bar in water? So someone wanted to explode lithium in water.
If it's anyone, it's definitely him.
Yeah, Leon.
Haven't had time yet.
I thought about it, and having worked with ammonia at -30, the prospect of working with lithium at over 200 degrees and under 10 bar of pressure, that's an absolute nightmare experiment. It really is. What's more, 200 degrees might not be enough. Yeah, I mean, it'd be interesting to try, but later.
Yeah, someday.
Oh, see, Leon, I wanted to send you the ground samples from Cape Verde at some point. I will send you a message on like Twitter or something. Oh, bismuth.
My bismuth crystal has broken.
Oh, I have a bit bismuth. Wait a second, where it is.
One of these days, I actually want to make some of these, right? So these I just These you can buy for like a couple of bucks.
A bit. Oh, wait, I'll take it out.
Now we're getting all our fun stuff out again.
Samples.
Yeah, it's a bit. And it's heavy.
So what you got, like a kilo of bismuth or something?
I think 500 grams. It's what it says.
It's just amazing.
It was damn cheap. I saw it and thought, you got to buy this.
It's even a German seller, isn't it then? Wismut.
I think I could... No. There, it's not saying where it came from. Here? Nope. I don't know where I bought it. It's quite some time ago.
So one thing that I've never really understood is with water, it's a strange one in that the solid actually floats on top of the liquid. Normally things, when they solidify, when they freeze, the solid sinks in the liquid.
Yeah.
Bismuth is another one of those where the solid actually floats in the liquid, which is one of the reasons why you can get these really awesome crystals of bismuth.
Yeah, they grow.
And I've never really worked right but with water, it's very easy to explain because you've got these hydrogen bonds that are actually more effective at holding the molecules apart when it's a solid, and then when they become disordered, then whatever, it becomes more dense. With something as simple as bismuth, right, where there is no molecular, it's a metal. Where the hell do you get the increase in volume on freezing?
It might have like a weird crystal structure.
Yeah, I keep on meaning to look it up, but I just never got around to it.
I mean, gallium does it too.
Really?
I think so. Actually, I'm not 100% sure. I would have to check. I don't have some gallium here. I've got gallium-indium alloy, but that doesn't count.
As far as I know, gallium expands too when you when it's hardens.
Okay.
Because I saw a video and someone put it in a glass bottle, and when it solidifies,
oh yeah, I remember. Yeah,
the bottle broke.
Yeah, Cody, right? It was too warm in the recent days. My gallium melted.
Oh.
Struggle of the summer.
I don't have gallium here, but I have indium here.
Yeah, me too. I've got indium gallium alloy, which is actually even cooler.
So indium's, I've seen you can get it all over the place, but it's fairly toxic stuff, yeah? Or it's just
Indium is non-toxic.
It's incredibly inert. Like, it doesn't oxidize that quickly.
Gallium, that's certainly true. But indium...
From indium, you can take a bite without any harm.
Yeah.
That's weird. We used to use indium seals on the vacuum stuff, and I was told that, you know, indium was I never checked it out. But yeah.
I have taken a bite out of indium before, and I didn't die, so it should be fine.
But I think with a lot of these things, the toxicity is usually hugely overstated.
Yeah. Same with even nitrous oxide. So we said breathe it and you're essentially dead. It's really not that bad.
Yeah.
It's not that great, but...
Even with things like nerve gas, right? Yeah, all right, technically a drop will kill you. But you take a look at the people they actually are killed with it. They convince them to rub it on their face. And even at that, okay, the guy who the North Koreans killed didn't have much of a chance. But the Novichok people both survived. You know, it's just toxicity. Indium has biological role, although its compounds are somewhat toxic when injected into the bloodstream.
Okay, fair enough.
So I was told that it was like lead, but it doesn't look like it's even that bad.
Yeah.
Even mercury isn't that bad.
Yeah, that's
mercury.
the one thing that I hate about the European Union is it's impossible to get your hands on mercury without buying it through an institute or something.
Yeah, the same with lead in a few months.
You're kidding.
Everything with more than 3% is prohibited to sell. 0.3% of lead.
That's
So you can't just buy.
Yeah, you can't get solder with lead anymore then.
Oh shit! I have to buy quite a lot of lead solder then.
I have a bit, but I have buy more. I have to buy more because
That's just stupid.
Yeah, and the new regulation on protection of your data. It's so you can't even do a TeamSpeak on in Germany anymore. You can't make a website. It's so horrible.
So indium gallium alloy does this, which is cool.
Yeah, it's like one of the lowest melting.
Yeah, well, this is only indium gallium, so it's only 16 degrees. So if I put it in cold water, it actually freezes.
Yeah. Hey, that doesn't adhere much.
No, there's some hydrochloric acid in there. That's why.
Ah, right, okay.
So actually it doesn't even coalesce very well. So you've got these little bouncy balls, and over time they do coalesce somewhat. Yeah. There you go. Kind of neat thing I just did for a couple of years ago.
Did once make an
And I just broke it. I literally just broke it.
Oh no.
Oh.
Now I have indium gallium alloy all over my floor. I might have to go and clean that up.
Yeah.
Yeah. Oh well, no worries.
I once made an alloy from bismuth, tin, and lead, and it melts at around 96 degrees. And the brother of my father heard from this, and thought a bit, and then thought, when a building is burning, the wires in the air system have somehow to disconnect when it burns, so it can't get through this in another room. Normal solder melts too late, and because he heard this from me that there are alloys which you can solder which melt pretty soon, he thought, maybe to use this. He made a patent, and now he's selling it.
Yeah.
It's kind of cool that I got him an idea.
So what the hell brought on the European Union to ban lead? I mean, forever you've been able to. It's one of the few things that you can buy on eBay by the kilo.
Well,
for roofing or anything. Divers' weights is another thing that they use it for.
And there's something more. Zinc is banned in cosmetic products. Zinc oxide and so on. I don't want to.
I can forgive a lot. I mean, it's just way too much nanny state stuff. That being said, I mean, you go on eBay and you can buy things like sodium and potassium, whatever, sulfuric acid. No one gives a shit. Why not lead? Lead's harmless.
I will still buy lead, but yeah, I am pretty much okay with chewing on a piece of lead because it dissolves. It doesn't dissolve that well in water, even the oxides.
Yeah. This sort of says I'm not fast enough. I buy. Yeah. Gotta buy your solder quick.
Yeah, there's indium everywhere. Thankfully, I have nothing made out of aluminium around. So, oh well. So my wall's a bit silver now, but whatever.
Does indium attack aluminium as well?
Probably not, but the gallium's enough. And the worst thing is that the gallium oxidizes, and now I've got like black stains everywhere. But that's okay. I'll clean it up at some point. It's okay.
Bummer.
I have to get more indium now.
Yeah, so indium I saw, again, you can buy it by the kilo on eBay.
Oh,
it's fairly expensive though. It's like a few $100 per kilo, yeah?
Yeah, something like that.
My cable is too short. Barely. Oh, no, I got it.
Everything is silver and black. Oh, well.
So why is it gone black? It's the gallium, you say?
I think, well, it oxidizes, and then also if you just have gallium on your hands, they also go really black. I think it's just really small droplets of metal.
I got something here.
Okay.
So you can show you it's... Oh. Oops. There you go. Everything goes black. And also everything goes silver. So...
Oh, yeah. It sticks really good to surface.
Yeah. Oh, well. So the stuff I got from Cape Verde, that's the real cool stuff here. It looks literally just like Mars. It's just...
Oh! You went to Fogo?
Cape Verde, so Sal.
Ah, Sal. Okay.
And it's actually apparently really close to the stuff you get on Mars as well. So I tried to grow
Mars. It's like perovskite, perchlorates, yeah.
There are some perchlorates, but essentially it's mostly volcanic, and you got this iron trioxide everywhere. Yeah,
Bartel,
pretty similar.
You don't have to make copper chloride for PCB edge. You can just use hydrochloric acid and hydrogen peroxide. It works too. It works even better.
Yes, and then you get copper 2 chloride anyway, which will aid it, and then it gets better. It gets better over time. Just leave it open and it regenerates. I have to go for a second now.
Yeah. I recently bought this on eBay.
A lightsaber.
No. Lightsaber would be awesome, but this is awesome too. It's a scintillation counter with some.
That's what I was about to say. Photo multiplier. Yeah.
Yeah, with electronics. It's quite old, I think 40 years, but it still works. Even with it makes some weird things. I have to check this, but yeah.
Is the crystal so clear?
Oh, I don't know, but
I want to have a look at it. Unless it's not sealed, then don't, because yeah.
No, it's not sealed, but I don't want to take it out there.
Yeah.
The weird things it does is when you touch the metal here, it counts, but when you don't touch it, it counts a bit, but not as much as when you touch it. And when you don't touch it, and you put something like radium in front of it, it stops counting. No impulses get through. Yeah, something weird goes on there. But when you touch it, you get more counts when you put something radioactive in front of it. So yeah.
So where'd you get that from?
eBay for 115 euros. It was really cheap.
Yeah. From Russia?
No, from Germany.
Okay.
Not that far away, even. So yeah. I am almost completed with my vacuum chamber, but the seal isn't as good as I wanted. I think I broke it a bit when I pried the top off. So I have to redo the seal.
So you were glued? The seal was glue?
No. I made some kind of putty with the with silicon and starch. Put it on and put the lid on. But it was stuck too well to the lid, and yeah, it didn't want to go. Yeah. Well.
So this time you're going to put it around it instead of into it, right?
Sorry?
Just say like you should seal it from the outside instead of the inside next time.
I don't really know if that's possible. I have it here. This is my little vacuum chamber.
It's got to be said, that thing is pretty awesome. How thick are the walls on that again?
The walls are 1 centimeter thick.
Yeah, that'll take a...
I have the lid here.
Back here.
But it's a bit messy because I tried to fix the seal yesterday and it didn't work. That it is here for letting some gas in.
That being said, even at that, that's a lot of pressure to put on a 1 centimeter wall for a vacuum chamber that size. Are they glass or are they plastic? Are they perspex?
Polycarbonate, is it?
Oh, okay.
Yeah, but it's tight. Before I get the lid off, after the seal hardened, but after that, I wasn't able to get it tight again.
Okay, so the seal it dries solid, right? It dries hard.
A bit. So it's rubber-like.
Oh,
it's
God.
silicon with starch.
Oh, nice. Because I'm thinking, maybe you could put something gelatiny over it when you're using it.
This would
something that would not be able to seep in, obviously, but something that air could not get through either.
Okay.
And because it would be in a gel form, I mean, you'd have to wipe it off each time, but it could make your seal better.
What is this about?
Because he's having trouble achieving his vacuum chamber, right? So I'm trying to figure out a way to seal it better.
Yeah, I just came back. That's why. Okay, vacuum chamber. Can't you just use silicon?
Again?
Silicone is an obvious first choice. If you're really keen and you don't want to take the top off again, if I remember rightly, with Perspex, you can just use a solvent. You just dissolve the Perspex, and yeah, you just rely on that for the seal. It doesn't come apart after that.
I like that. Yeah.
I have to get it apart to. That's the chamber where I want to make the lithium experiments with vaporizing lithium in.
So you regularly have to take it apart and put it back together. So I mean, you regularly have to open it and then close it again.
Yeah,
right.
The top.
But I mean, you're right. Vaseline or something like that does work, but you have to reapply it every time.
Oh, okay.
Yeah, but until he can figure out something better, it's a decent workaround because it will work.
But it might not give you very high pressures. Well, very low pressures.
What sort of pressure you after for this anyway?
Good point.
I want to pump all the air out and replace it with argon multiple times. I think.
In which case, it's fine. It runs that much pressure then, basically.
I think my pump goes down to 0.05 torr.
That's pretty good.
11 meters of mercury.
Don't know. It's
that's what torr are. Torr is a meter of mercury.
Okay.
A good American unit, or a good imperial unit. Now I think about it.
But I do use it quite a lot. Like when I was working in a lab with like quantum computing, quantum gate stuff, they use Tor as well, or Millitor for that matter.
I always thought bar was just the most obvious unit to go for. A bar is basically 1 atmosphere. And then you know what you're talking about: 1/10 of an atmosphere, 100th of an atmosphere, 1,000th of an atmosphere.
Yeah. Well, actually, at some point, I don't even say Millitor anymore. I mean, you start saying things like 2.3 times 10 to the -6 torr. Just give it.
Once you're down to 10 to the -6 of anything, there's not much there.
Oh wait,
they're incredible vacuums, though.
0.2 Pascal.
Right. So I mean, if you're vacuuming that out each time, you only need to do it twice, probably, and you'll have a complete argon replacement in there.
Okay.
If anyone wonders, soap works. Soap against indium gallium alloy.
I think I have to rebuild the whole thing at some point. Because I think I got cracks in it.
So I'm looking at this again. It's entirely Perspex, yeah? I'm just thinking, wouldn't you be better off with a metal box with a Perspex window? Because then your seal is much easier, you know, for the taps. It's a beautiful Perspex box, don't be wrong. But,
I want to put a few thousand volts across these terminals, and with a metal box, it's hard to insulate.
Yeah, okay. I got it. I remember now. This.
I got my 2 microfarad 80 kilovolts capacitor bank over there.
Well, now I think about it, at that point, aren't your metal taps going to be a problem?
These taps won't be that much a problem.
Oh,
just ground.
Okay, because I got it, because you'll be not connected to anything to Earth to those taps. Just plastic tube, yeah.
This won't be connected. I connected here and here. I machined it especially for this. It's can you see it?
Yeah, I got it. Yeah.
This here is screwed in. Do I have something here to get it out? Oh yeah, that works. I got the screw, and here is a hole drilled in, and I machined this flat with a lathe. So I have maximum the words. My English isn't that good anymore. I was better at school.
So you want to apply a very high current through this for a short period of time, yes?
Yeah.
What is in German?
Wow.
There's just no words, just numbers. Yeah.
Oh, I forgot.
This is like a feed-through thing. Or...
So I'm thinking now, if you've got a nice box like this, you can basically, like you've got at the moment, you vac it out, fill it up with argon, and then you just basically have an induction coil around your lithium in the middle of it, and you just keep pumping heat into it, yeah?
I could do that.
How hot do you want to get it? I mean, you only need it to, well, it's 1,000 degrees. It's quite hot, actually, but...
I could use... wait a second.
So I'm interested now.
I
think
once
lithium might be 2,000.
An induction heater could work, but how well does lithium conduct compared to copper?
Lousy, I would expect, but
okay, then it's good, because this only works well when the resistance of the material I want to heat up is greater than the coil I have. I don't want to make the coil out of silver, because it's quite expensive. But then induction heating could work. In the other room, I got...
So I just checked it out. Boiling point of lithium is 1,300 degrees, which is, on the grand scheme of things, fairly accessible for things like induction heating.
Okay.
Copper is about 6 times more conductive than lithium.
Ah, okay. Yeah, that's okay. Okay, then it would work. I haven't tried it yet. I didn't even open my lithium block there. It's still sealed.
Although now I think about this, and just from my experience of doing lots of stupid things like this, my money says that you're going to end up with some melted lithium holes in the bottom of your Perspex box. They won't go through, but that's one thing I know about Perspex, is it bears scars very easily and very well.
I could use an end cap, or I could use... I have still a few graphite crucibles, and I think even a silicon carbide crucible. But I think the silicon carbide would be torn apart by the lithium.
I suspect so too, that lithium, it reacts with strange things. Silica, for certainly, it'll just eat straight through silica, sorry, and glass. What was the graphite? I think you'd be okay with.
Okay.
But I don't know for certain. It might be that it does some weird. Lithium is chemically weird, but you don't really care whether it does chemically weird stuff, as long as it's not too fast and as long as you get your vapor pressure of lithium. Yeah. So, I mean, you probably only need 1,000 degrees to get your vapor pressure of lithium.
Yeah.
And you could calculate it.
But it's probably tabulated, yeah. I mean, if it boils at 1,300.
Clausius-Capellas equation. I should know that. I have my exams in 3 weeks. I should probably know this. Oh well.
Lithium vapor pressure. There we go. And yeah, that looks about right. So yeah, 900 degrees, you've got a tenth of a bar, tenth of an atmosphere at 900.
Okay. From that, give me 10 minutes and I can tell you how much you need for 10 atmospheres.
You want 10 atmospheres?
Yeah, well, how much does he want? How much does he want?
No, not in this thing.
Oh, okay.
That's a different experiment.
Okay.
10 atmospheres is going to be, oh god, best part 2,000 degrees, I'd reckon.
There are two experiments. One with exploding liquid lithium inside of water, and to get it liquid inside of water, you have to pressurize the vessel. But I think Cody's lab could do this better because he has a really big pressure tank where
also
he could.
He's insane.
Yeah.
Not
not that much. Friends tell me I'm more insane than him, but
yes, they're right.
Maybe.
Guy drank cyanide. Okay.
Well, that one doesn't bother me too much because you take a lethal dose, you dilute it by a factor of 100, and then you take a few drops. You know, it
shouldn't be that bad, yeah.
Because it turns out, right? Well, we did something very similar actually. We were interested in the differences between zinc and magnesium. Both the ions are basically exactly the same size, and both should behave very similarly. So we just diluted these solutions up and tasted them. It tastes disgusting. Zinc tastes much more disgusting. But interestingly, before we actually got around to the tasting, but after we'd done a load of the initial experiments, we looked up the toxicity, and it turns out the zinc chloride's quite toxic stuff. At 3 grams is a fatal dose. Which is only like 1 or 2 orders of magnitude more toxic than cyanide. But just how disgusting it tastes once diluted down to some millimolar type concentrations and a few drops of it, it would be one of the most disgusting ways of committing suicide ever.
I recently found something in the internet. There are tin compounds. Organic tin compounds are incredibly toxic, more toxic than cyanide.
I can believe it, yeah. A lot of the organo... Yeah. Nickel tetracarbonyl, I think, is one of the most toxic compounds out there. And so it's used to refine nickel. But yeah, nickel tetracarbonyl is just obscenely toxic stuff.
Oof. Reminds me of methyl mercury.
Yeah, it's about the same. I mean, mercury itself is not too bad. You make it soluble, and you got all sorts. It bioaccumulates is the problem.
Yeah, mostly in fat and brain. And
yeah, bits that you need, you know.
yeah. Oh, and Cody drank a homeopathic solution of mercury nitrate.
Again, I mean, as long as you're dilute enough,
He had.
doesn't really matter. But you got to be certain about your quantities here.
I mean, there was a
you
10
gotta
to
be
the
careful not to
-3
slip.
chance of even having a single atom of mercury in his solution. So
Yeah, okay. So once you've got a couple of orders of magnitude wiggle room, you're safe.
He had 35 cups with water, and he made a solution in the first one, put 2 drops into the second one, stirred it around, put 2 drops in the next one, and so on.
Yeah.
It's so dilute.
All you got to remember is not to drink the first cup. You know, it's easy to get mixed up, the first and the last.
I think he put numbers on them.
Yeah. There are stories of some guy in a safety lecture drinking from the wrong beaker. And killing himself. Difficult to believe, but most of the things that you can drink that'll kill you are disgusting. But
kind of makes sense.
It's just one of those things that gets you a Darwin Award is for killing yourself in a safety lecture.
I was actually about to ask.
Yeah. So there's a wonderful piece of footage of an American police officer giving a lecture on gun safety to a bunch of kids and actually shooting himself in the foot, literally shooting himself in the foot. You just got to look it up. And it just couldn't have been more comedically timed. You know, this is I forget it was a 9mm, you know, semi-automatic, whatever. I don't know. I am the only person in this room qualified to handle this gun, and he literally puts it in his holsters it, and sort of shoots himself within about 3 seconds of saying this. And you utter spanner.
One smart guy.
And then we wonder about, oh my God, U.S. education.
Well, then offering seriously as a solution to this, giving teachers guns.
Ugh.
Yeah.
Well, I always said you should just have it like fire extinguishers. Just have guns and like glass boxes, and in case of if something happens, you just break them, and there you go. Perfect solution.
Yeah, guns and teenagers is a bad combination.
Yeah.
Something got into my mind. I heard about the UK that they want to prohibit communication that's encrypted.
Oh, for real?
Yeah. The UK is the other side of the spectrum.
It's the utter nanny state.
Yeah, you can't do anything anymore. Just sit at home and watch YouTube.
Oh,
no, you've got to watch the unoffensive YouTube.
Yeah, true.
Do you know the guy?
Yeah, do you see the Count Dankula stuff? Dankula.
That was truly ridiculous.
Yeah, I just couldn't believe that it was serious. The guy's just sort of messing around with his dog, and he ends up being prosecuted for it. I mean, yeah. There are times when I'm just so glad I don't live in England anymore.
Yeah, I'm going back to Germany.
Mind you, Germany's not far behind, yeah?
Yeah, Germany has its own problems. Sorry.
It's up the same alley as Lawrence Southern getting kicked out of the country. It's the same level of crazy.
So, I mean, with Lawrence Southern, I absolutely disagree with them kicking around the country and all that sort of thing. But the one thing I hold a grievance against what she was doing sort of with the people in the boats in the Mediterranean, because they were, I mean, the people crossing the Mediterranean are essentially fleeing a war zone. And that war zone is firstly on the border of Europe, and secondly, in part caused by Europe, in that we were instrumental in deposing Gaddafi. Yeah, we sent planes over and bombed him, that sort of thing. And yeah, I mean, if it's people just sort of coming over for whatever reason, yeah, okay, you've got to have border control somewhere. But people fleeing war zones, that's a little different. And she was like shooting fireworks at him. I don't know. What do you think about that?
Oh, do you know the guy Photon Induction on YouTube? He makes something with high voltage, and so he lives in the UK, and he's trying to get his wife from India to the UK, but it's really a shit show.
It really is.
Well, yeah. I mean, the UK government is just cataclysmically incompetent. Yeah, it's just pathetically discoordinated.
Mm.
But no, I'm just curious what everyone else thinks about you know, the people coming over the Mediterranean, because yeah, I looked up the statistics some time ago, and it turns out that, you know, people make a big show about, you know, the people drowning, and it's about a 1% chance of you actually dying crossing the Mediterranean, which is still, you know, if you put yourself in their shoes, yeah, there aren't many things that you can do that you have a 1% chance of dying doing. And Libya, for certain, is an absolute failed state. There is, you know, the last I heard is they actually have legitimate slavery in, you know, it's a country worth fleeing from.
Wow.
Yeah. And the thing is, people that take these ways are actually in trouble, and they are refugees. So if anyone should be helped, it should be these people. Because obviously there are also people which exploit it, essentially, right?
Yeah.
But these definitely aren't the ones that do. So,
I mean, then the ones that the Libya, I feel somewhat more. We were instrumental. These were essentially our neighbours south of the whatever, and all right, they were run by a dictator, and the dictators were, you know, if you're going to bomb anyone, the dictator's about as good as anyone. But the thing is, then Europe just sort of sat by whilst the country dissolved into a complete shithole.
yeah.
Now, you know, if it had done that all on its own, kind of like Syria, then yeah, that's the way it goes. But you know, usually you want to take an interest in the countries on your border. But yeah, never happened. So yeah, I mean, when it comes to law and denied access to the UK, I mean that's just bloody stupid.
Yeah.
It's not as stupid as the Dankula thing. That was just off the spectrum. But yeah.
Today my clock shows a bit higher than a few weeks ago. 0.11 microsieverts per hour.
Hey.
It's still a pretty deep zero background.
Yeah.
Especially for Europe, that's actually pretty good.
I think the highest I've got was 0.15. But
again, that's a decent zero. That's zero.
It's so low. With my experiments with the tube and 120 kV or so, it was a bit more.
Yeah, but if you take a scintillation counter, just leave it in a room, you will find it's probably like 10 becquerels or something like that.
Ooh. I think I have an audio of this on my phone.
So I just did a calculation, and lithium at 10 bars, well, 10 atmospheres, boils at approximately 1760 degrees Celsius.
Okay.
Hey.
Yeah, I only have to melt it.
At which point I call my.
Yeah, so actually not that much hotter, because at 1 atmosphere it's like 1330.
Yeah.
But because it's exponential, yeah. There you go.
Where's the video? Oh, there it is. When I tried to make a gamma spectrum from radium and thorium.
Yeah, it just run.
That's not background anymore, but okay.
Yeah.
Yeah.
It's got a heartbeat to that one.
But to be honest, even like 10 millisieverts an hour isn't too bad for a couple of minutes. And I wouldn't want to stay around.
Nah.
But
well, you get 4. You can get 4 on a plane, right? It's only twice what you're gonna.
Oh, but I mean millisieverts.
About that.
That's a spectrum I got,
okay,
but
yeah,
a gamma spectrum, but it's not that accurate. Something is wrong with this. I have to show up what's wrong and fix it.
But I mean, like 10 millisieverts an hour, you probably won't want to stay around. But even that wouldn't be too bad for a couple of minutes. Yeah.
Yeah.
I mean, you get much higher doses doing a CT scan, anyway. So
that's what I was thinking. I mean, yeah, even if it's 1,000 times background for a day, that's yeah, it's only 3 years worth of radiation.
Yeah.
And yeah, you get 70 years of that normally with your life. So, but I mean, I'm just curious. I mean, where do you think it's all going with the with the free speech thing? I mean, that's
it's scary.
Yeah,
it's honestly scary.
But it doesn't seem that there's any coordinated attempt to either destroy it or defend it. It's just that you can end up with completely ludicrous lawsuits like this, and there's no conceivable way that you can defend this as being the public good.
But I mean, if context doesn't matter anymore, and it's just about what people think, people can abuse that.
I mean, it's the ultimate irony, right? In Germany, there have been anti-defamation laws since the end of World War II, which you can sort of understand, which is fine. You can understand why Germany might have been a little sensitive to that thing after World War II. But now, if you got caught doing that in Germany, would you have had the same reaction? Because I mean, I know like people who grew up in Germany, and they said, yeah, sure, there are all the laws against Nazi signs anywhere, even in computer games, but everyone grew up playing Wolfenstein in Germany.
Yeah,
it's like no one. They were laws on the books, but no one gave a shit about them.
That's a good question. I'm not sure. People are easily outraged about these things. Like it's a touchy subject, but also people also really they like to joke about these things a lot, actually. Because forbidden topics are always the most interesting. But I don't know. So it's actually they speak about it a lot, and we have stupid people which like Holocaust deniers and stuff like that, which have actual campaigns, and they are not being stopped because free speech. So I don't think it would have been.
But they are. But those are actually. I mean, across about half of Europe, there are Holocaust denial laws.
Oh, really?
Which, yeah, they sort of made sense, you know, immediately after World War II. Now, not so much.
Okay. I didn't even know
Well, I
that.
mean, it's one of those things that if you're going to move on, you've got to kind of accept that, yeah, this did actually happen. And but
I mean,
you know, now it doesn't make any sense. It's bloody history.
Yeah, exactly. Stir it up. I mean, there was something similar-ish in the last few days, where essentially Nazi group had like flyers against like I don't know, homosexuality and stuff like that, and they were trying to stop like some parade thing. Because they didn't like it.
I haven't heard about this one yet.
I just saw it on Reddit. I think it was today or yesterday.
Oh, okay.
And the police didn't do anything there. They checked on it to make sure everything is going okay. But in the end, unfortunately, well, not unfortunately, but they have to write as horrible as it is to others. And we kind of have to allow that, because otherwise we see what happens in the UK, right? And
yeah, especially
with the Count Dankula thing. If the government can just decide on how they feel, a future government can do that too, and they might actually have bad intentions, which is scary.
Well, yeah, I mean, ideally the law should be separate from the government, but yeah, I think just having laws like this on the books where I can't even remember what the details were of why they said it. It was just he was convicted of being grotesquely offensive or something.
Yeah.
And it was very, very clear that it was just a joke.
Yeah, and it's not even just a joke. It was actively against.
Exactly.
It,
right. He was teaching the dog to be evil.
Yeah.
Because it was funny.
And he literally said the
you have to teach your dog to be a Nazi.
Yeah, exactly.
Yeah.
And
if he had been teaching his dog to bite Jews or something, then yeah, maybe.
Yeah, exactly. Yeah, it's a very different thing. But just mentioning it and therefore it's bad? No. It's just not how it works. So context apparently doesn't matter anymore.
But the thing that I thought it was obscene that it ever went to court in the first place.
Yeah.
And doubly obscene that he was found guilty.
I mean, he is appealing it now. On the next court.
But first, it should have never gone to never gone to court.
Yeah.
Secondly, there's some guy who's going to decide whether the prosecution is in the public interest. He should have thrown it out. Then the judge should have said, "This is bollocks," and thrown it out.
Yeah.
And he didn't even do that. He found him guilty.
Well, let's hope it goes through with the next higher instance.
I mean, I never looked at that. What was the judge? What was the judge like? Did the judge know what email was? Did the judge know what the internet was?
I have no idea. That's Germany's biggest problem currently, isn't it?
Yeah, that you've got entire generations that things have just moved so much since their time.
Merkel said in 2013, the internet is new to us all. Merkel, the Chancellor of Germany.
Mm-hmm.
In 2013, the internet is to us all. A bit late, like 20 years late, but
yes. So if I remember rightly, she's also got a PhD in physics.
I've read her paper. It's actually kind of interesting.
Yeah.
I think she can't really do what she actually wants because she has to obviously keep the party happy.
In that minute.
Yeah, the party has to be kept happy. The main people, well, the main demographic that votes is 60 plus. 50 plus. With 50 plus, you actually got like 50% of the voting people. So, yeah. There's just no investments anymore. Which is
no investments in sort of public infrastructure.
As well, yeah, especially when it comes to internet. There was an attempt to actually have nationwide glass fiber, which was stopped because like essentially glass fiber in every town of Germany, which would make sense because glass fiber is easy to upgrade because you only have to upgrade the ends. You don't actually have to upgrade the
fiber optic, we would call it, but
fiber optic, glass fiber. Yes, yeah, true. Which was stopped, not because of financial reasons, but rather because it would create too many office jobs, I think, or it would. It was stupid. It would essentially cause the automation to happen quicker. But that's the future. So.
So I was actually in a couple of weeks back, and it looks very okay. I was in Berlin, so I know where the Berlin's representative, but it seemed pretty well run.
That's very true. I can't complain. It's just the internet speeds are incredibly low. You essentially have very bad coverage for like network. Like mobile network. There are no new investments, or very few.
It's quite okay in Germany with internet?
Not really. I mean, before I moved to the UK, I had less than 1 megabyte per second. Megabit second, sorry.
I think it depends where you are.
Yeah.
What I'm in the Eifel National Park. There are places I don't have any internet at all, but
I mean, you would expect that, to be honest.
In North Rhine-Westphalia, in the places where there are more cities, the internet is better.
Yeah, but I think on average we are place 40 something in internet speed. Which is crazy because Netherlands is right next to us and they are, well, essentially top. So
yeah, that's right. But here where I live, they have glass fiber, and I'm my download speed is 400 Mbit.
Oh, okay, that's great.
Upload 20
Mbit. Decent.
You're in the Czech Republic currently, aren't you?
Yep.
How good is the internet over there?
The institute is phenomenal.
Oh yeah, okay.
Like, I mean, it takes. I don't know what connection they've got, but Jesus, if I upload a video from there, I could upload a gigabyte in less than a minute, which is it's blisteringly fast. I mean. I remember when I first started uploading videos, which was in America, you would have like half an hour whilst it was uploading. During which time, okay, I'll give you some time to sort of write in descriptions and all that sort of thing. Hold on, the Institute's Wi-Fi and internet, Jesus.
Wait a second. Did you have an upload like my download?
Yeah, so I mean, we do lots of molecular dynamic simulations there, and those things are big and chunky to move around. But I just want to. One of the things that struck me about Germany is everyone is very diligent about following the crossing signs. You know, so when you get the green man, you can cross the road. Everyone waits for that, which in England, it's like no one would ever do that. It's if the road's clear, you cross it, you know. Whereas in Germany, you would get, you know, an empty street and people would still be waiting for the green man.
The problem is when you go over a red traffic light, you can get charged for this.
But as a pedestrian,
yeah, if you cross the road, if it's bad, because in the UK the traffic the traffic code, the highway code, sorry, you can essentially cross any road except for motorways whenever you want. I don't think you can in Germany. Also, I think the lights are just much better in Germany. Like, you don't have to wait 5 minutes to actually cross the road.
I think it costs 50 euros when you cross a red traffic light.
In which case,
you got the point.
I came up with 2 solutions.
Okay.
If you go through as a car, yeah, that's a big problem. If you go through as a pedestrian, also a problem.
Yeah.
Oh, yeah, that is if you're a pedestrian. Yeah.
So in England, you have to look left and right to make sure no traffic is coming. In Germany, you have to do it twice. Once to check there are no police cars, and once to check there's no traffic.
To be honest, people still cross. It's just...
Yeah, but it's like... yeah, you're right.
Speaking of that, actually, when you were in America, did you do your McDonald's diet?
Yeah, and I lost a couple of kilos. So it wasn't as good. I mean, it's living the active lifestyle, walking up mountains, that sort of thing. Awake and moving around all the time the sun is up, which is 16, 18 hours a day. But yeah, I lost weight there as well. Came back fitter and healthier. I mean, I often thought a lot of that dieting stuff was just complete bullshit. That, it doesn't really matter what you eat. If you're living a really active lifestyle, your body will find its equilibrium there.
Yeah, well, in the end, it's energy conservation anyway, so
yeah. I mean, I often wanted to track down where the excess goes. That if you're leading an active lifestyle, you've got to burn off those extra calories somewhere, and I don't believe that it's all just in the mechanic. I think your resting metabolism just burns off what it doesn't need.
Okay.
But I don't know. I'd love to track that down sometime.
How would you actually measure like the heat output of a human? Because it's like 100 watts-ish, isn't it?
Yeah, that's about right. Yeah.
Well-insulated room.
The way that I was doing it previously was you just measure the breathing rate, because it turns out what you breathe out is fairly constant in terms of carbon dioxide and oxygen. So therefore, all you need to is how much volume have you been breathing. But of course, that gets tricky when you can, measuring a 10% difference in how quickly you're breathing is not so easy.
Yeah.
So I was thinking of, you can do a video of yourself while you're sleeping, which is actually a really creepy thing to do. I once did a time-lapse of myself while I was sleeping. And when you see yourself asleep and vulnerable, you feel like there is a monster watching you. It's just really horrible to see yourself asleep. It's like, oh, wake up! There are people watching you. But one of the things that was interesting there is you can sort of see the breathing rate. And so I was curious if you can see the different breathing rates after you've, say, been drinking. Because I've often thought that, your breathing rate changes during that, but I'm not sure.
I bought myself this little thing. It measures the oxygen content of the blood. And
those things are awesome, and they're like $20, yeah.
Yeah,
your pulse and oxygen content.
This thing.
Now I've got a challenge for you, right? Because we did this all throughout our lab. Is if you hold your breath, how long does it take for the oxygen level to go down?
It takes quite some time.
Not only, yeah. So it's one of those things. Actually, long before you really need to breathe before the oxygen level starts going down. Because of course, the need to breathe is the carbon dioxide building up. But the thing is, it takes a long time for the oxygen levels to go down, and they come back up very quickly. So we had this competition who could get their oxygen levels the lowest. And it's actually really hard to do.
This thing here shuts down at 50% oxygen level. It thinks someone isn't right, and it recalibrates.
So it's normally about 90, blood oxygen. I forget what the units are.
Yeah.
If you can get it down to 70, you're a hero. Yeah, try it sometime.
I got it down to 55, and then this thing thought there's something wrong.
Yeah, damn straight there's something wrong.
I dive some when I in my free time sometimes, and I can hold my breath quite some time.
Okay, that's really impressive. Yeah, okay, maybe none of us had the experience with the holding our breath like that. So the FLIR 1 cameras, they're okay.
It's 60 by 80.
It's a shitty resolution. They're buggy as hell. But if you want something quick and dirty that shows you where hot spots or cold spots are, they get the job done.
Yeah, and there's a different company. It's the Seek Thermal, which make up to 240p.
That's a very respectable resolution.
And they're about the same price, like $300-ish, $200, something like that. But they don't have a camera with that, and they don't combine the image of a normal camera and the thermal. It's thermal only. Yeah.
I don't have one yet. It's too expensive right now.
Yeah, me neither. I'm currently trying to build a tunneling microscope like this.
What?
It's super easy. You can do it with less than 100 pounds. Well, $100.
A tunneling microscope.
Because all you need, in the end, first of all, you don't need a vacuum chamber, because the needle is so close to the surface, oxygen doesn't fit in between. Well,
okay.
You control it by using just a piezo buzzer, which you cut into 4. Like in one of these normal speakers, and then you just cut it into 4 pieces, and then you got your X, Y, and Z, and then that's it. I mean, the rest is just some vibration isolation.
I was about to say that's the next thing. Is I've been to some of the small labs, and they have entire buildings dedicated to low vibrations.
Yeah,
single molecule imaging, that sort of thing.
Oh, there we go. There we've got one of these. Yeah, and if you cut it into 4, you got X, Y, and Z, obviously.
The problem with cutting is they break not necessarily where you want them to.
Yeah, it's barium something, isn't it?
And this thing is one from a smoke detector, and it's driven resonant, I think, because here is a additional tab for feedback.
Oh, I see. Fair enough. And you can do that by voltage probably later. Yeah, but people have done that for less than $100.
Wow,
it's kind of neat. I might actually find. This page is the most interesting, really. And you get nuclear resolution, so.
That's crazy.
It is pretty neat.
When I experimented with alloys, I still have some silver for the next tries. I also use a bit titanium in the alloys, and it made it a bit difficult to melt. But with aluminium, it wasn't that hard at all.
What?
I think.
Aluminum has a super high melting point.
No.
Aluminium, it's like 600 degrees. Titanium
What
is
am I
pretty high.
mistaking it for?
Sorry?
Then what am I mistaking it for? Because I remember from jewelry class that
Tungsten's.
Tungsten.
No, I'm pretty sure I wanted to make aluminum jewelry, and they told me no because it requires too high a temperature.
It's difficult to work with because it oxidizes. Maybe that's what. Maybe they mean the oxide layer.
That could be.
Because aluminium oxide takes like 1,000 degrees to melt. Thunder just left.
When you do when you make an alloy with silver, titanium, a bit bismuth, and aluminium, you have an alloy. Where the oxide protects it and it stays shiny.
Oh, okay.
Even when you wear it on your body.
Oh, okay. See, that's one of the things that also. Sorry, you go.
But when you want to, gosh, what do you call it? Not solder. The other thing that you do when you actually melt things together.
Weld.
No.
Welding? Brazing?
No. The thing that you have to do with an arc usually.
Welding.
Welding.
TIG welding, usually. Yeah.
Thank you. So for that, the oxide is going to get in the way.
That's true. Yeah.
So it's still hard to work with for jewelry purposes.
You can use borax to.
Well, we use the borax for the silver as well, but that melts away. That.
You can weld aluminium, but you have to clean it well, quite before, like literally before you weld it. I think it's just once it sticks together, the aluminium stays on the outside. And there he is. Welcome back.
Hi guys.
Hi.
Sorry about that. Don't know what happened there.
The good thing with my silver alloy is, it has a high silver content, and silver, you can braze it, you can weld it. It works quite good.
You can cold weld it.
I didn't try that yet.
But it's difficult, I think. See, one of the things I always want to do is like gold coat a tiny magnet, and I just put it in my finger.
Don't use gold.
Cody
tried it, and it.
Yeah, but he didn't coat it very well, did he?
I think it's better when you use one of the.
Like a Teflon coated one or something like that.
Wait a second. Titanium nitride.
That's a good one, actually. I have to spot
that they use for artificial bones and stuff. No, that's what I mean.
Yeah,
it could work for that.
But titanium coating is difficult.
I would still. I have some of these magnets here, but I think it's better when you do a coating of gold too, above this.
Probably, yeah.
Because it's so thin, I think there are holes in the coating.
Yeah. I will figure out something. I might just sputter it.
If you want, I sent you some of mine. I have 200 of them.
Oh wow. What were you using them for?
Oh,
you only got 10 fingers.
I didn't use them yet. because I wasn't sure if the coating is thick enough, and I don't think it is. Yeah. I found a UK seller that coated me some, but it was quite expensive.
I can get them coated in the university. It's not a big issue. I do thin film stuff. It's fairly expensive, probably like £50 or something, but it's okay.
Yeah.
Another thing you might want to try is what's it called? Molybdenum disulfide.
You buy it in spray cans.
It's
molybdenum disulfide.
You can buy it at Obi.
Really?
Yeah, I know because when we were in Germany, we were looking for some stuff to coat the nozzles with, and we found graphite sprays and molybdenum disulfide.
No, sorry, that's not what I mean. Yeah, molybdenum disulfide, obviously, yeah, you get it in grease and stuff. No, I mean molybdenum disilicate. Sorry. Disilicide. Because that's really cool stuff. It's conductive. It's a conductive ceramic, which is stable in normal atmosphere, up to 1,800 degrees Celsius, which is insane. So it's a really cool. Well,
as far as I remember, this stuff is extremely expensive.
Yes, but you can make it using thermite.
Oh, that's good.
It's a molybdenum oxide silicon powder thermite, which gets up to 2,400 degrees Celsius.
I once made copper thermite with aluminium. The burn rate is quite, I would say, high. One puff and it was gone.
Thermite ones.
It's with aluminium as fast.
Yeah. Oh well.
I used a circuit like this to melt my metals in a graphite crucible. You have to put 48 volts and 20 amps here, and here goes the coil, and this is the place for the transistors. They are somewhere there. I made them to stick on because they burn up so fast when something goes wrong. Yeah, so I use this circuit also to drive my transformers, my self-wound.
Yeah, I don't have space for that. I only have a tiny room here.
Oh, my transformer is like this big.
Yeah, but not all these things Oxford, right? Or UK property market. It's insane.
But yeah, titanium is hard to melt.
Yeah. I might actually have to go soon.
Oh,
actually,
okay.
I should probably wrap it up. It's getting fairly late for me here too.
Yeah.
So.
Okay.
Well, yeah, you're an hour ahead, aren't you?
Exactly. Yeah.
Yeah. I mean, for Marta and the others, it's probably broad daylight, but yeah.
Not so bad. Yes.
Now it's dark here. But
yeah, it's broad daylight. I'm gardening.
Ah.
Yeah.
It is broad daylight. I'm gardening.
Okay.
Okay, guys. Well, it was great seeing you all. And look forward to doing it again sometime.
I probably won't be here next time. Probably in Russia somewhere. So have fun, everyone.
Ooh.
Yeah, it's internship.
Okay. Cool.
Good luck.
Yeah, thank you. Have fun.
Okay. Bye.
Bye.
Good night.
Good night.
Bye.